Oh, you are really study hard. We're diving straight into the world of data analysis and visualization using Python. Think about the sheer volume of data generated every second. It's staggering. The challenge isn't just having data, it's making sense of it. Python has become the go-to language for this very reason, offering a powerful yet accessible toolkit for professionals like you to transform raw information into actionable insights. Let's break down the core components of this Python powerhouse for data work. First up, NumPy. This is your foundation for numerical computing in Python. Forget basic lists. NumPy gives you multi-dimensional arrays and efficient mathematical operations, essential for handling large datasets without breaking a sweat. Then comes Pandas, arguably the most popular library for data manipulation. Think of it as Excel on steroids, but for code. Its data frame structure is perfect for tabular data, making cleaning, filtering, and analyzing data incredibly straightforward. For visualizing your findings, we have Matplotlib and Seaborn. These libraries turn your data into compelling charts and graphs, helping you see patterns and communicate results effectively. And finally, scikit-learn brings machine learning capabilities right into the mix, allowing you to build predictive models and uncover deeper insights. Let's zoom in on Pandas because it's truly indispensable. At its heart are two key structures, the data frame and the series. A data frame is like a spreadsheet or a SQL table, perfect for structured data. A series is simpler, just a one-dimensional array of values, often representing a single column. What makes Pandas so powerful is how easily you can manipulate these structures. Need to select specific rows or columns? Indexing and slicing are incredibly intuitive. Got messy data with missing entries or duplicates? Pandas provides robust functions to handle these common data cleaning headaches. It's designed to make data wrangling, the often tedious process of preparing data for analysis, as painless as possible, letting you focus on the actual insights. Now, numbers and tables are great, but sometimes they don't tell the whole story. That's where data visualization comes in. It's about transforming those raw figures into something visual that speaks directly to the brain. Think about the difference between looking at a spreadsheet of sales numbers versus seeing a dynamic chart showing trends over time. Visualization is crucial for exploratory data analysis, or EDA, helping us quickly spot patterns, outliers, and relationships we might otherwise miss. It's also vital for communicating our findings. A well-crafted graph can convey complex insights much more effectively than paragraphs of text, especially when presenting to non-technical audiences. Libraries like Matplotlib and Seaborn are our main tools here, providing the power to create everything from simple plots to sophisticated statistical graphics. Matplotlib is the bedrock upon which much of Python's visualization power is built. It's a low-level library, meaning it gives you fundamental control over almost every aspect of your plot. Think of it as the canvas and brushes for your data art. Its object-oriented design allows for highly flexible and modular creation of complex visualizations. Whether you need a simple line chart to track trends, a scatter plot to explore correlations, or a histogram to understand distributions, Matplotlib has you covered. The real strength lies in its customization. You can meticulously control colors, fonts, axis labels, grid lines, and much more, ensuring your visualizations are not only informative but also visually appealing and tailored to your specific needs. While Matplotlib is powerful, sometimes you want to get things done faster and with better aesthetics, especially for statistical graphics. That's where Seaborn enters the scene. Built directly on top of Matplotlib, Seaborn acts like a high-level interface, simplifying many common plotting tasks. It's particularly strong in creating statistical visualizations, like heat maps, violin plots, and regression plots with minimal code. One of its biggest advantages is its pre-built themes and styles, which often produce visually appealing plots that are ready for publication or presentation without needing extensive tweaking. Plus, its tight integration with Pandas data frames makes it incredibly convenient for visualizing data directly from your analysis workflows. It's like having a skilled assistant who knows exactly how to make your data look its best. This isn't just theoretical stuff. Python is driving real-world impact across countless domains. In business intelligence, companies use Python to forecast sales, segment customers for targeted marketing, and analyze market trends. In scientific research, it powers everything from genomic sequence analysis to modeling climate change and even accelerating drug discovery pipelines. The finance sector relies heavily on Python for risk assessment, optimizing investment portfolios, and detecting fraudulent transactions. Even in healthcare, Python is used for analyzing medical images, predicting disease outbreaks, and contributing to new drug development. Essentially, if there's data involved, Python is likely playing a role in unlocking its potential. Let's walk through a concrete example, analyzing customer churn. This is a critical problem for any subscription-based business, figuring out who's going to leave and why. Using Python, you'd start with data analysis, exploring customer demographics, their usage patterns, billing history, support interactions, all the data points that might indicate dissatisfaction. Next, feature engineering. This is where you might create new metrics, like average session length or days since last login, that capture meaningful aspects of customer behavior. Then, you'd leverage machine learning libraries like scikit-learn to build a model that predicts the likelihood of churn. Finally, visualization is key to presenting these findings, maybe showing which factors are most strongly correlated with churn, or illustrating the impact of different interventions. This entire process, from raw data to actionable insights, is streamlined using Python. In conclusion, Python is far more than just a programming language. It's a superpower for anyone dealing with data. It equips you with the tools to transform raw information into valuable insights, empowering data-driven decisions across industries. Mastering Python opens up a world of opportunities. So, the next step is clear. Start exploring these libraries, experiment with real datasets, and begin building your own analytical capabilities. The journey of data mastery begins now.